Hi, I'm Alex Elias, and I'm a graduate student here at Rensselaer studying robotics, control, and automation. I also recently completed my undergrad here with a degree in electrical, computer, and systems engineering. My experience at Rensselaer has far exceeded my expectations, and I'm really thrilled that I get to stay here to study for another few years.
As an undergraduate, I took some excellent classes. Here are some of the most memorable ones. Data Structures was a very rigorous and very rewarding programming course in C++. Fields and Waves used Maxwell's equations to explain transmission lines, waves, and magnetic circuits. Signals and Systems got me thinking about signals using frequency and gave me a first taste of systems theory. Robotics 1 involved modeling and control of robots, including arms. Getting my degree in ECSE means that I gained multidisciplinary skills, worked on cutting-edge technologies, developed a deep, bottom-up understanding of the field, practiced making connections between topics, and used cool math to solve real problems. One aspect somewhat unique to Rensselaer's undergrad program is the amount of exposure you get to internships and research. For example, I spent 8 months at a co-op with Draper in Boston, and I conducted research at Rensselaer in wearable and autonomous systems for health monitoring applications. These experiences taught me a lot, confirmed how useful every single one of my classes was, helped me focus on what topics I still needed to learn, and helped me decide I wanted to go to grad school.
Throughout my undergraduate career, I was able to spend time with friends not only here in our gorgeous campus, but also going downtown to the shops and affordable, delicious food, or even going to parks.
Recently, I've continued to enjoy our city and campus by going to the farmers market Saturday mornings, going to Monday Night Jazz downtown, and participating in Rensselaer's Cheese Club. Now that I'm a grad student, I continue to take excellent classes like computer vision and optimal control theory. And I spend most of my time on a manufacturing research project with the United Technologies Research Center. It's a great example of cool research that comes from Rensselaer's excellent industry connections. The goal of this project is to improve the manufacturing process called deep rolling, where a roller applies high pressure to the surface of a metal part. This pressure causes deformation and residual compression in the surface layer, which not only smooths and hardens the part, but also prevents cracks from forming or propagating. This process has been typically done using CNC machines like lathes or tables. These machines are expensive and can't easily work on very large or complicated parts. The goal of my research project is to instead roll on the part using an industrial robotic arm, like one that might be used to assemble cars. These robots are cheaper, more flexible, and have larger workspaces than CNC machines, but they are also less stiff, which makes them difficult to control. That means we need to develop advanced control algorithms which incorporate accurate models of both the robot and the metal workpiece. My focus has been on developing these models. The robot model tells us the relationship between the torque we apply to each joint and the movement of the robot. To find this relationship, I made a gray box model of what this relationship should look like in terms of unknown parameters like joint mass or location of center of gravity. Then, I used experimental data to find these unknown parameters. For the model of the metal workpiece, we actually already have a finite element model which accurately shows us what happens when we apply pressure to the metal surface. However, this model is highly computationally intensive and requires a supercomputer to run in a reasonable amount of time. My goal is to tremendously simplify the model to give us very similar results, but with much less computation. We can do this by reducing the number of degrees of freedom and converting from 3 spatial dimensions to just 2 spatial dimensions, and by using data from the original model to find viscous, elastic, and plastic parameters. Making this deep rolling model is very exciting because, as far as we know, no one has done something like this before. I'm looking forward to seeing how much faster we can make the model run while still giving similar results.
So, even though this project has so many mechanical aspects to it, I'm still using a lot from what I learned in my undergraduate degree. In fact, coming from electrical engineering gives a really fresh perspective on all these niche problems, and I'm so excited to see where my graduate degree takes me next.